welcome to the Small Talk episode 6. Today we are going to discuss how does SSL work and the HTTPS works. So early days in the internet, actually there was only the HTTP was there, and it was not a secured protocol. In that case, it's vulnerable for the middleman attack and several other vulnerabilities. So in order to cater that requirements, in the 1994, the Netscape team developed the secure socket layer, which is a cryptographic protocol which provides the secure connection between the computer networks. So the original version, the version 1.0 was not released to the public because it has a lot of security flaws, and they have released the version 2.0 in 1995. And that also has a lot of security flaws. So they have immediately released the version 3.0 in the 1996. Later, the successor of the SSL is the transport layer security, the TLS, which is built on top of the SSL 3.0, and later it becomes the internet standards for the security. So for the HTTPS, which transport messages with the encryption, and HTTP use SSL for the encryption. And the SSL is developed. It has a layered protocol which consists of the 4 sub-protocols. It's in between the TCP/IP layer and the application layer. So in the SSL record protocol, first it fragments the data, then it compresses the data, and for the data integrity, it will add the MAC, and after that it will encrypt the data, and finally it will append the SSL record header. So then we will discuss how the SSL do the encryption. In the it has 2 stages. First one is the SSL handshake, and then the actual data transfer. So in the SSL handshake, it uses the asymmetric cryptography. That means we have the public key and the private key, and the public key is shared with everyone, and anyone can encrypt the message with the public key, and only the person who has the private key who can decrypt the message. And for the actual data transfer, it will use the symmetric cryptography. That means the same key will be used for the encryption and the decryption. So in the first SSL handshake consists of 4 steps actually. So the client sends the hello message, including the version number and the list of supported CIPHER suites. So actually, if you go for the deeper into the CIPHER suites consist of 3 things. One thing is the key exchange algorithm, and the encryption algorithm, and the hashing algorithm. So it has a predefined format. As in this example, the key exchange is the RSA, and the encryption algorithm is the AES, and the hashing algorithm is the HMAC SHA-256. Likewise, there are a set of key exchange algorithms, encryption algorithms, and hash algorithms supported in the browsers. Actually, these CIPHER suites differentiate based on the browser version and the browser type. So as I mentioned, this is taken from my Chrome browser and the Safari browser. As you can see in here, the supported CIPHER suites are different in the browsers and the browser versions. So also there are different versions in the SSL and the TLS, and the supported key exchange algorithms. Some of them are supported in the later versions, and some are not supported. So the encryption algorithm as the same. These are the AES algorithm you can see, and the RC4 algorithm. Those are some of the algorithms that we are using in the for the encryption in the SSL. And for data integrity also, hashing algorithms also, there are a lot of hashing algorithms available, and some only few are supported by the later versions due to reasons. And after the client send the client hello message to the server, server responds with the server hello message, and the server should decide what is the CIPHER suite that it supported. So the client send set of CIPHER suites to the server, and server decide based on its configuration, it will decide, okay, what is the CIPHER suite that it select for this particular session, and it also will send the its certificate. When the server selecting the CIPHER suites, actually this is an example. Let's say there's a browser, Firefox browser, and the server supports the TLS 1.2. In that case, the Firefox browser supports set of CIPHER suites. Let's say the AES 128 and the AES 256, and obviously the AES 256 is the more strong CIPHER suite than the AES 128. So in that case, if we disable the AES 1281, so in that case, server will select the AES 256 CIPHER suites. But if both are available, in that case, server will by default select the AES 128, which is bit weak, not stronger than the 256 one. The reason is actually in that case, we can configure the server in order to set what is the minimum level of the what is the CIPHER suites that it should support, and it will not select the highest CIPHER suites. It will select what is the sufficiently secure one, because based there it will consider a set of other reasons like performance, how up to which level it should do the computation. Based on those things, it will decide the sufficiently secure one instead of the highest available CIPHER. And after that, the server will send the hello message with the supported CIPHER suite, and it will send its SSL certificates. This certificates includes the public key of the server. After that, the client authenticate the certificate with the certification authority. The client, let's say the browser, it has the public key of all the trusted certification authorities. With that one, it can validate the certificates. If the that authentication success, in that case, the client will generate a pre-master secret, and that pre-master secret will be encrypted with the public key of the server, because in the certificate it already contains the public key of the server. So the client will generate the pre-master secret, and it will send that to the server side. Meantime, the client will generate do a set of operations on top of that pre-master secret, and it will generate the master secret, and it will ultimately generate the session key. So once the pre-master secrets come to the server side, it will decrypt. First it will decrypt the pre-master secret because it has the private key. So it will decrypt the pre-master secret from his private key, and it will do the same set of operations on the pre-master secret to generate the master secret and the session keys. Ultimately, both client and the server will have their session keys, which will use to encrypt and decrypt the data communication between that. So after that, it will follow the symmetric key cryptography in order to transfer the data in between them. Also, the flow that I have explained, the handshake flow will take 4 steps, but it will differ based on the implementation. TLS up to TLS 1.2, there will be 4 stages, but when it comes to the TLS 1.3, actually in the first stage, it can send, okay, these are the suggested, not only the list of supported CIPHER suites, it can suggest okay, these are the keys that we can use for the communication. So in the TLS 1.3, it will reduce the number of steps for the handshake process. So that is the end of the presentation. This is the time for the questions. Thank you.